Hey everyone, today we're going to be looking at solving equations with pronumerals on both sides. But before we jump into pronumerals on both sides, I just wanted to recap solving 1 and 2 step equations real quickly. Now, when we're solving equations, we want to isolate our unknown, our variable, right? So that might be an x or y and m, doesn't really matter, okay? But our goal here is to get this guy by himself, all right? And the way we're going to do that is we're going to work furthest away from the x when we already have the x on one side only. So in this case here, to get that 2x by itself, I'm going to subtract 5 from both sides, leaving me with 2x is equal to 12. And then to isolate that x, I'm going to divide by 2, leaving me with 1x, or just x, is equal to 6. Okay? Same idea here. I'm going to work furthest away from my unknown by subtracting 7 to begin with. I'm going to end up with negative 3y is equal to 22. And then we're going to divide by negative 3 on both sides, leaving this as an improper fraction. Okay, so we're working with moving numbers around on each side of the equation. Now this will look a bit different when we have pronumerals on both sides. So in this case here, if I was to kind of write this out, I've got 3 x's and then just 4 units. And then I've got 1x, and that's 12 units, right? Now we know that we can take 4 units off of both sides, right? So if I was to remove 4 from here, to keep it balanced, I'm going to remove 4 from there. So I'm going to start by subtracting 4 from each side. That's going to leave me with 3x is equal to x plus 8. Okay, seeing that we've got 8 blocks left on that right-hand side. And then the x's work the same way, okay? Because we know that the x has to be equal to each other, I can take 1x off of both sides here. And in doing so, I'm going to be left with 2x on that left-hand side. And so in this case, I can treat x just like I would any other number, okay? If I want to move it around, I'm going to subtract x from both sides. Then for that final step, I'm going to divide both sides by 2, and x is equal to 4. Now don't forget that you can sub these values in to double check them. So on this right-hand side, I've got 4 plus 12 is equal to 16. And on this left-hand side, I've got 3 times 4 plus 4, so 12 plus 4, which is equal to 16, okay? So x's, y's, all of your variables work the same way as long as you're working with those like terms, okay? Now it's going to seem awkward when you have negative x's, so in this case here, I've got 9 and then plus negative 2x, so minus 2x, is equal to x plus 3, okay? Now this method here, if this is how you wanted to picture it, if I kind of add a blue x here and a blue x here, and I do that to both sides, right? So that positive x, the idea is that this positive and negative x will cancel each other out, okay? So in this case, I am adding 2x to both sides to make that negative 2x just into 0, okay? In doing that, I'm going to have 9 is equal to 3x plus 3. I can get rid of 3 on each side, so I can subtract 3 from each side. I'm left with 6 is equal to 3x, and then dividing by 3 is going to give me x is equal to 2, which once again you can sub in to check, okay? So if I've got negative 2x, to get rid of that, I'm going to add 2x to both sides. Now it works the same if it's just written out instead of with the diagram, right? But in this case, I like to avoid negatives as best I can. So what I'm going to do in this case here, and it doesn't matter whether you subtract that 7m or add that 3m, but just to avoid those negatives, I'm going to add 3m to both sides. So I'm left with 10m minus 3 is equal to 37. I'm going to add 3 to both sides, and I've got 10m is equal to 40. And then if I divide both sides, by 10, by 4, but I divide it by 10, I'm left with m is equal to 4. Okay, same idea here for this one. I'm going to start by adding 2x to both sides, which leaves me with 5 is equal to 5x plus 30. I'm then going to subtract 30 from each side, leaving me with negative 25 is equal to 5x, and then dividing both sides by 5. Okay, so we treat x or y or whatever it is you're using just like any other variable. Okay, and if you do end up with an improper fraction, then that is your final answer. Okay, if you do want to double check your work, then you just sub straight back in. Now feel free to pause here, but I'm going to go through these ones as well. Once again, I'm going to start by working with that n. I'm going to subtract 4n from both sides, leaving me with 8n minus 72 is equal to 90. I'm then going to add 72 to both sides, leaving me with 8n equal to 162. And then dividing both sides by 8, I'm going to be left with n is equal to 162 over 8. And then if I was to simplify that down, I would have n is equal to, oh, that's a tricky one. Let's start by dividing by 2. I'd have 81 over 4. Okay, so this here would be your simplified answer, and that's just what your answer is. Okay, now this one here, I'm once again going to start by adding 5x to both sides just to avoid those negatives. I get 13 is equal to 23 plus 7x. Subtract 23 from both sides. I've got negative 10 is equal to 7x. And then divide both sides by 7 would give me x is equal to negative 10 over 7.